Hi everyone, welcome to this video. In this video we are going to talk about domain name system. We will find out why it is required and how it works. So let's begin. So whenever anybody asks you what DNS is, you should really think about two things. One is name and second one is number. By name I mean domain name or a website name like google.com or facebook.com or amazon.com, anything, any domain name. And by number I mean IP address, or number is like IP address. By number I mean IP address, by name I mean domain name. So DNS is really converts your domain names to IP addresses and vice versa, but it really converts your domain name to IP addresses. This is DNS. This is the task of DNS. Now why do we require DNS? Don't we just type IP address in the browser and see the website? Yes, you can, but what happens with DNS is there are billions of websites running on the internet. You cannot just write every IP address in browser and try to find a website. You need a simpler way to do this. So we created domain name system where we will type like abc.com, xyz.com or example.com, and it will take back us to the website itself. There is no need to type these IP addresses, and with IPv6 the problem is even greater because IPv6 is 128-bit addresses. Nobody can write that long address in a browser and go to that website. He will just write google.com or example.com and the DNS will transfer it to that specific IP address. So this is the task of DNS. Simply you can think of a phone book in your house. We used to have those phone books to type all the or the contacts in your phone. So you cannot remember each and everyone's contact. So what you do, you decide to save a number and a name. You can remember the name easily. DNS works in the same way. So I will just go to the details how it works. So suppose you purchase a PC, a new laptop or a new PC, and you are connected to the internet. And you go to your browser and just type mail.google.com. You are trying to open Gmail, so it is mail.google.com. First, what happened? The PC will go to its DNS server or address. So whenever your PC is, in last video we talked about DHCP. So DHCP really gives your PC an IP address, a subnet mask, a default gateway and a DNS server IP address. So DHCP will give all this information to your PC. Then your PC will, if I go to browser and type mail.google.com, your PC will go to this DNS server address. Suppose it is 8.8.8.8. Suppose this is a DNS server address which you have in your device. So it will go to 8.8.8.8. It will go to the DNS server, and first the process will happen. It will try to find out where the .com is. So it will go really to right to left. .com is a top level domain. So first it will go to root level domain, which are 13 servers, 13 DNS server around the world, you can say. These are highly scalable and highly secure, and there are 13 root level servers in the internet which represent by a dot, a simple dot. Then there are many top level domains, which means .com or .in or .uk or .gov or .net. There are many top level domains. So this mail.google.com comes under .com top level domain. Then it will go to google.com, which is an authoritative name server. Suppose abc.com or your facebook.com. These will be an authoritative name server. then it will go to mail.google.com. So inside that also there will be some domains like ax.google.com or bx.google.com. There will be one domain like mail.google.com. Then it will try to find out that IP address, and then it will return to your PC or your browser through your browser. Then your PC will go to that IP address on the internet. So this is how DNS works like behind the scene. So this is about your DNS. So this is the hierarchy for DNS. First there is root level domain, then there is top level domain, then there is authoritative, and there is a resolver, and there is a stub. So I will start with what stub is. Your PC will be having a DNS cache. Suppose I went to mail.google.com and its IP address is 10.1.2.3. This is IP address of mail.google.com, suppose, and I go to this website quite frequently. So my PC will save this IP address in front of mail.google.com in its cache or in its stub. So that PC itself is a stub resolver. So first your PC will check it in yourself that whether I have this domain name or I do not have this domain name. Then in the second step it will go to a resolver, which will do all these root level, top level, authoritative, domain level pings by resolver. So let me draw a diagram which you will understand it better in that manner. So this is a PC, this is your resolver. This usually happens in ISP side or your internet service provider side. PC will itself will be having a stub. It will first go to stub and check that whether it has the IP address of anybody, facebook.com or example.com or not. Suppose it does not find an IP address in its stub or its cache, so it will go to resolver, which is your DNS address or DNS server's address. This resolver, what it will do queries behalf of this PC. So resolver will first go to the root level domain. Root level domain will return a query. Then it will go to the top level domain. Then it will go to authoritative level domain, and then it will send back the query. So there are 1, 2, 3, 4, 5, 6, 7, 8. 8 processes are happening behind the scenes. 8 pings or 8 packets flowing back and forth. 8 pings are happening behind the scene, and you are just typing google.com and the website is opening up. So that is the whole another process. But only trying to find out this DNS or this IP address, there are these many processes which are involved behind the scenes. So DNS uses UDP. One more thing to remember, it uses UDP, it does not use TCP. It uses UDP port number 53. So there can be a question in the interview, or you really have to understand this, why it do not use TCP, why it only uses UDP. So in TCP what happens, there are a 3-way handshake and one for closing the connection. So there are 3-way handshake in TCP. In UDP there are no concepts of handshake and all. So suppose this is the first packet, it goes to resolver, then there is second packet, it goes to root level domain, then there is third packet coming back and it gets lost, and we are using TCP. So what will happen, there another 3-way handshake will happen, 3 additional processes will happen, then it will come back to resolver, then it will again go back to top level domain. Suppose it is lost again in between, then in this top level domain also 3 processes will happen, again the handshake will happen, again the handshake will process will come back to resolver, then go to authoritative name server. So in any case, if a packet is getting lost, there is another 3-way handshake is happening in the case of TCP, but UDP is free from this. So we will use UDP because this is not a very complicated process. The server DNS name already is publicly available. We do not need to secure anything sort of that here in the case of DNS. So we will be having a simpler process. That's why we follow UDP. We do not use any sort of TCP in case of DNS, and that is the reason for that. So let's jump back into our lab section in Cisco Packet Tracer, and we will establish a whole DNS system for us. So I'm here in my Cisco Packet Tracer. I will quickly draw a topology. Suppose I will this is a web server and this is my DNS server, and I have two laptops and they are connected to a switch. So I will quickly draw this topology and get back to you. So yeah, our topology is ready. Suppose this is our DNS server and this is our web server for suppose abc.com. I will just assign them, all of them, IP addresses so that they can communicate with each other. So I will just give this PC an IP address of, for gateway I will give it 10.1.1.255, and DNS server I will give the address of this DNS server. So suppose I am going to configure it at 10.1.1.50. So this is the address of DNS server. So I will just configure this for DNS server also. We can leave it just like 0000. There is nothing to do in the DNS. And the web server I will assign, and no need to assign any default gate. Now these three devices are having all the IP. Let me just delete this PC. We don't need it right now, so I'll just delete. So yeah, all of the devices are having IP addresses. So now I'm going to configure first a web server. So if you go to this server 127.0.0.1, okay, .0. So this is the website which I want to access from this laptop. So this is running on this web server. If I go to services, go to HTTP, this is running on this web server. I will quickly check all the services are off or not. TFTP let off. Okay, all other services are off. This website is running on abc.com. abc.com means this, whatever this is, a simple website. Quickly go back. At the DNS server, what I will do, I will go to services. I will just first shut all the HTTPS down. I will go to DNS. I will go to do it on, and I will go to a record, which is an IPv4 record. I will type the name as abc.com and the address of 10.1.1.100, which is the address of this domain name, and I will add it to the list. According to the DNS server or the DNS cache, the abc.com is point to 10.1.1.100. So whenever I go back, I go to laptop and I'm going to a web browser, I will not type the IP address of the website, because that is very difficult to remember. There are hundreds of websites. So I will just type abc.com, and it is going through the DNS. It is asking for a DNS address resolution, and it is going to the server. So this all process is happening behind the scene. So this is how you can quickly build a simple DNS topology in Cisco Packet Tracer. So thank you for watching this video, and I will see you in the next one with some other topics. Thank you for watching and take care.